Hello, this is Srnka, and I'm going to be solving the web assigned projectile motion question number 18. The question is, when chasing a hare along a flat stretch of ground, a greyhound leaps into the air at a speed of 10.3 meters per second at an angle of 13.4 degrees above the horizontal. We're going to be solving for the range, aka the final distance to the x, and for how much time he's in the air. So the S and the C steps are to sketch our motion and to make a coordinate plane. As you can see, I made a coordinate plane. You want to clarify that this is the positive y direction up on the y, and this way is the positive x direction for our motion. And we want to clarify our starting point, our 0, 0, and just sketch out our motion, what it's going to look like. Now we have to list out both the x and the y components of our motion. By doing this, it will help us find which equation to use, because it shows us what components we have and what we have to solve for. So now that we've filled everything out, we can see that we're solving again for the final distance of the x and then the time. So we're going to try to find the time first, and to find an equation, we're going to look at what components that we have provided to us. You can see that we have both of our velocities for the y and the acceleration for the y, and we don't have the t, so we're going to use the equation v equals vi plus at. Now, before you plug in your numbers, you have to notice that the vi of the x and the y is 10.3, but that is the magnitude of the whole motion. So you have to do an equation to find out what the vi actually is for the y. What is it? As you can see, we have to multiply 10.3, the velocity of the whole motion, by sine of 13.4 to find the y, because sine is the y side, the opposite side of a triangle, and by cosine, the same thing for the x. Now we can plug our velocities into the equation. Now we have our equation. We are solving the x is time, and now we just have to use algebra to solve this equation. Now you can see that we found that the time of the motion was 0.488 seconds, so we can plug that in to our list, and we're actually going to use that to solve for the next equation for the final distance in the x. What equation are we going to use? As you can see, we're going to be using the d equals di plus vit plus 1/2 at squared equation, because with the components we have, it allows us to do this. So now we can just look at our list and plug in all our components. Now you can see we plugged in all our numbers, and now we're going to just plug into our calculator and see what we get. Now after plugging that into our calculators, we can see that the final distance of the x is 4.88 meters. So now we have found the range of the dog's leap, 4.88 meters, and the time in the air, 0.488 seconds. And there you go. That's you solved the equation with collapse. Good job.